Men of science tell us that telescopes show the Earth to be a planet, just like Mars or Venus, a planet rotating about the sun. But how could a telescope show this? After all, you can't stand off in space to look at the Earth through one. Really then, on such evidence, is the Earth a planet after all?
Well, I'm not so sure a telescope wouldn't help to show that the Earth is a planet. Speaking, it is true with hindsight, it seems to me that looking at the planets with the telescope, we are apt to learn many things we didn't know before we had one. But how a telescope could teach us things about the Earth is indeed hard to imagine. Still, it wouldn't be the first time that science would have led us to believe things quite contrary to expectations, and even to common sense.
So potent a force is science in transforming our material civilization that very few of us question the statements made by scientists, even when they plainly contradict our ordinary sensory experience. Nevertheless, apparently absurd conclusions of science are justified. In particular, as this story unfolds, the dramatic effects on science of the introduction of a new instrument that enables the scientist to transcend the limits of ordinary experience will be seen. Now, to say that the Earth is a planet is to establish a similarity between the Earth and those star-like bodies, Mercury and Venus, Mars, Jupiter, and Saturn. The stars that we see on any given night appear to us to be a series of bright lights set out against the dark draperies of the heavens. These stars are usually arranged in groups. Groups have names like the Great Bear, the Little Bear, Orion's Belt, Cassiopeia's Chair, and so on. The assignment of stars to groups or constellations is, of course, purely arbitrary. They're intended to serve as an aid to memory. For instance, there's nothing about the group of stars which is called the Great Bear to suggest a bear rather than a pig or a beautiful maiden. But if we take the whole group of stars and arrange them in constellations or groups on an astronomical globe, which is like a globe of the Earth, except that instead of showing continents, we show all the different stars arranged here in constellations, we can represent on this globe the way the constellations at night rise in the east and set in the west. And as the year progresses through the seasons, new constellations will be seen in the night sky. Some of the other constellations will disappear. Now, the amazing thing about these stars is that although they appear to move in the course of a night through the heavens as a whole, the relation of each one of these stars to its neighbors is fixed and determined. It's just about the same today on a star globe like this as it was at the dawn of history. Now, for this reason, the stars are known as fixed stars. They're fixed with respect to one another in constellations, and each of these constellations is fixed with respect to the other constellations. But what we call the planets, Mercury, Venus, Mars, Jupiter, and Saturn, are brighter than the fixed stars, and their positions in the heavens are not fixed, either with respect to one another or even with respect to those fixed stars in the constellations. Now, the motion of a planet with respect to the fixed stars can't be seen in the course of a single evening, but a month is long enough to show that a difference appears between the place where we see a planet in the stars and where it will be seen at a later time. Here is a chart of the heavens. You observe on it that there is a series of stars that are shown and a single line which indicates the path along which Mars moves from one month to the next. So one of the features which distinguishes a planet from the fixed stars that we see in the heavens is not only the fact that a planet wanders with respect to the fixed stars, but that sometimes it wanders toward the east and sometimes toward the west. In fact, the very name planet comes from the Greek word planetos, which means wanderer. In other words, the primary distinction between a planet and any other star that we see in the heavens is that the planets actually do wander while the other stars are fixed with respect to one another. Now, if we turn to the historical record, we find that from ancient times, say the period of the Egyptians, until about a little more than 300 years ago, most people thought that the Earth was at the center of the universe, that all apparent motions observed in the heavens were actual motions. It was believed that the Earth was fixed in space, that it was immobile, and that the heavens turn around the Earth, as we see at night when we watch the heavens rotate. We see the sun and moon rise and set. We see the planets rise and move through the heavens, moving with respect to the Earth. Now, the sun and moon are not fixed with respect to the stars, and so they used to be called planets too. So the ancient list of planets includes, first of all, the moon and the sun, and then Mercury and Venus, Mars, Jupiter, and Saturn. From these 7 wanderers or ancient planets, we derive the names of the 7 days of the week. Sunday is, of course, the sun's day, moon is the moon's day, and Saturday is named after Saturn. This old system astronomy, in which the Earth was considered to be at the center of the universe, had the planets Mercury and Venus and Mars, Jupiter, and Saturn, which look like stars to us when we go out at night, to be real stars. And like the other stars that exist in the heavens, these planets were thought to revolve around the sun and to shine by some inner light just like the other stars. And so there was a simple homogeneity in the conception of stars. The planets and the fixed stars both moved around the Earth, and the Earth was different and was not a star. The sun, it was held, was like a star. It shone by its own light, and so it was plainly reasonable that the sun and the moon should move around the Earth. The moon, however, the nearest of all the astronomical bodies to the Earth, was conceived to be a little different. It was halfway between being Earth-like and star-like. The moon, of course, doesn't look like the fixed stars or the sun and the planets. It doesn't have any light of its own, and it was soon realized in Greek times that it was a huge, smooth, opaque ball which receives its light from the sun. Now, if this is so, half of the moon is always illuminated by the sun, while the other half must remain in darkness. Over here, we have a model to show why the moon gives us the appearances that it does. Over here, I have a large opaque ball, and over here, I have a spotlight which can serve to illuminate that opaque ball. Suppose I were to look at it from this direction, then what I'd see is the whole disk of the moon illuminated, a condition that arises when the moon is full. Suppose now I were to look at this opaque ball and spotlight in this direction, then the part of the moon which is illuminated and which I see is just 1/2, which corresponds to the condition of the moon when we see the first quarter. If I move over here and look at my spotlight and opaque sphere from this direction, then we see the appearance of the moon in the last quarter. And finally, if I look at the globe and spotlight from this direction, what I see is simply the opaque or unlighted side of the moon, but I may be able to notice a very tiny crescent on one side, giving us the appearance of the moon in its very last period of visibility or in its first period of visibility. This type of demonstration was actually conceived by the ancient Greeks, and it was conceived by them to explain why the moon shows the phases that it does. But the fact is that even though people generally conceived that the moon was more Earth-like than the other stars or the planets or sun, it was still generally thought that the moon must be a perfect sphere and that some unknown phenomenon, some optical phenomenon of which people had no idea, was responsible for the markings on the moon. Now, this is discussed in all the older literature. For instance, in the third book of Dante's Divina Commedia, there's a long discussion between Dante and Beatrice as to why the moon, which is a perfect sphere, should nevertheless look to us the way it does, some parts being dark and some parts being light, and even having the appearance sometime that there's a face to be visible, the face of the man in the moon. Well, this system was challenged in antiquity, for there were a few people who had the idea that maybe the Earth isn't at the center of the universe. Maybe the sun is located at the center. But of course, there's an obvious objection, because this scheme implies that the Earth and the planets, Venus, Mercury, Mars, Jupiter, and Saturn, are all alike, since all of them move in the same way around the sun. The idea was very repugnant. One of the primary reasons that nobody liked it was that it implied that the abode of man, this solid Earth on which we stand, that this was something which is rushing through space. How much more comforting to think that the Earth is standing still. Then there's another problem. Because in view of what man considered the universe to be like, it was much more reasonable to think that the Earth was unique, different from the planets and not the same. For the Earth is the only place where man lives, and presumably the only place where life had been created. So the Earth was really, in most men's opinion, different from the planets and surely not the same. And because it was different, it had a special role, a special place in the order of heavens, and that was to be fixed and stationary and to be located at the center. In the year 1543, the Polish astronomer Copernicus published a great book which is called On the Revolutions of the Celestial Spheres. In this book, Copernicus advanced the theory that all the phenomena of the heavens can be explained by assuming that the sun is fixed at the center and the planets move around it. Here is a diagram of the Copernican system as it appeared in print in the first version of the Copernican system in the English language. Note the sun at the very center and the planets moving about the sun in a series of concentric orbits. Copernicus suggested that the Earth was to be thought as only another planet moving around the sun. Now, the book that I hold here is actually a printed facsimile of the original manuscript of Copernicus's book, which survives today some 400 years after it was written. It was a very difficult book. It was hard to understand because it was based on complex mathematical arguments and has many formidable calculations, long series of tables. Copernicus, in the preface, said, "Mathematics is for the mathematicians," and it was generally agreed that a reader would have to be a very skilled mathematician to master the contents of this noble book. Now, one of the main reasons that this book of Copernicus did not at once excite men's imaginations and give rise to those later controversies was the obviously absurd implication that the Earth is only another planet. The mere fact that the planets have a wandering motion with respect to the other stars surely doesn't make them in our minds any the less stars, for a star is a bright luminous object and presumably it shines because it has some inner light of its own, and the Earth isn't such a body. It's made of earth and dirt and clay and living material, and no one would conceive that it shines the way stars shine. I think we can see, therefore, how philosophically absurd it was, and how contrary to every possible conclusion of common sense applied to experience, to take that statement of Copernicus, the Earth is merely another planet. Planet indeed. Why, anyone had only to go out at night and look at the heavens, see what a planet was like, to find out that it was like a star and not like the Earth. And when he looked at the Earth on which he stood, it was perfectly clear to him that the conclusion of Copernicus was absurd. The Earth was not a planet. Then, in the year 1610, everything that I've just been talking about was upset. It was upset by the publication of one of the most important books in the history of scientific thought. The book was called The Message of the Stars, and it was written by the great Italian scientist Galileo Galilei. Here we have his picture, and up in the corner of this picture is shown the instrument in a somewhat fanciful reproduction, a cherub looking through a tube-like device in order to see what the heavens are like. Even more than a dozen years before this book had been published, Galileo had become a convert to the ideas of Copernicus, but he hadn't found any way of convincing anybody that the new system was better than the old. And then, in 1609, 1 year before that book was published, Galileo heard, as he said, rumors that a new instrument had been made by putting two lenses together. No one knows where this device was invented, when, or by whom. Presumably the invention was in Galileo's native Italy, since a telescope had been brought to Holland, which said on it that it had been made in 1590 in Italy. And by 1609, a number of such instruments had appeared in Holland. They were all made by combining two lenses together. Now, one of these lenses was a positive lens. By positive lens, we mean that it's very thick in the center and rather thinner at the edges. This positive lens has the property of enlarging. And if we take a piece of cardboard on which some writing appears and place that piece of cardboard in front of our optical bench, and then place the lens in front of it, and now look through the positive lens at that piece of paper with the right printing on it, we see that it's very much enlarged. The second lens is a negative lens. It's a lens which is very thin at the center and rather thick at the edge. And this lens has just the opposite property. This lens makes things look small, or is a reducing lens. And if we place this here, then as you can see, the letters look very, very small. Now, in making the early telescope, two such lenses are used. The positive lens placed here, the negative lens placed here. And if I now look through this combination with the negative lens near my eye and the positive lens far away, we get an enormous magnification, as you may see, something that makes things look very large, or that makes us have the possibility for the first time of seeing what distant objects are like. This was the first telescope. Now, the modern telescope is somewhat different, but the principles of this early one are still used. It still is often called the Galilean telescope. It's used in the common opera glasses, in which we have a negative lens here placed near the eye and a positive lens placed here, just as in the combination of lenses which we showed a moment ago. Now, when Galileo heard the rumors of this new instrument, he went at once to his workshop and began to experiment with combinations of lenses, and he quickly produced such an instrument. And when he had done so, he recognized that the one thing this instrument might really do was to answer the question as to whether the Earth is unique and different from the planets, or whether those planets might be like the Earth. And he thought that he might even demonstrate that the conclusions of Copernicus were reasonable and not absurd. The first thing he looked at was the most prominent thing in the heavens, the moon. And here is a woodcut made from that early book, The Message from the Stars, which shows what Galileo saw. Our telescope enables us to see more detail, and to us the moon looks something like this. What's most impressive is the way the moon really looks something like the Earth. Here are obvious mountains sticking up, and here are what appear to be oceans or seas, and here is a kind of coral atoll like we would see in the Pacific Ocean. Here are continents, and here even are islands. With one view through the telescope, that old distinction between the Earth and Moon disappeared. The Moon was obviously not a smooth, opaque disk. It was certainly Earth-like. Later on, Galileo found that there really isn't any water on the Moon, and so presumably there is no life, but it was plain from that very first view that the Moon is corrugated and rough and full of mountains like the Earth. Here we have a close-up of the Moon as seen through the modern telescope. There are little dots of light that can be seen here and here. These are mountains, and Galileo realized that these mountains were so high that they could still catch a little bit of the sun's light, even though their lower portions were in shadow in the dark part of the Moon. Galileo calculated what the distance would be from these bright spots to the boundary between the dark and bright part of the Moon. And from these data, he computed the height of the mountains. They came to about 4 miles, or about 2/3 as high as the highest mountains on the Earth, like Mount Everest. Now, at certain times, Galileo found that the telescope showed that a certain amount of light was being reflected into the dark part of the Moon, a light which couldn't be seen easily with the naked eye but with the telescope. In this picture, we see on one side the Moon as it normally appears to us, a sort of crescent, and then the remainder of it shows us the carefully seen part that shows through the telescope, in which we can see the fine markings indicating that a certain amount of light must be getting into the dark part of the Moon. Where could it possibly come from? Galileo studied this question at great length, and finally he concluded there was only one possible place: sunlight, light from the sun striking the Earth and being reflected into the dark part of the Moon. Now, this was a great discovery, and we can't overestimate it, for it shows that even though the Earth can't shine from any inner light, it does shine, and it shines because it reflects the light from the sun, just as the Moon reflects the light which it receives from the sun. So, said Galileo, if there were an observer on Mars, he would see the Earth shine just as we observers on Earth see Mars shining. Now, one of the most interesting of all the discoveries that Galileo made with his telescope was the fact that around the planet Jupiter there's a system of 4 moons, and these moons move around Jupiter just as our own moon moves around the Earth. Another similarity between a planet and the Earth. Nobody could say anymore that only the Earth has a satellite or companion, a moon, and is unique. Jupiter has not only 1 moon, but 4 of them. But probably, of all the discoveries that Galileo made, the most important for the Copernican system was the appearance of phases in Venus. Here is a diagram. It shows us how Venus would appear to an observer on Earth if Venus, like Earth and Moon, is merely a dull piece of matter, a sphere, with no light of its own, but shining by reflected sunlight. Suppose we were to see Venus here. Then we'd see a perfect circle, just as before we demonstrated the condition to be when we see a full moon. Over here, we would see half of Venus illuminated, just as we see half of the Moon illuminated, and the same situation would obtain over here. At this point, we have the appearance of the Moon at first quarter and the other at last quarter. But when Venus is here, we would expect to see practically none of the planet, since the dark side is facing us, except that maybe we'd see a very thin crescent on this edge. Now, let me call your attention to one further fact. When we see that full disk, when we see the complete illuminated circle, then Venus is much further away from us than at any other position. And when we would see the crescent here, Venus would be at its nearest position to the Earth. Hence, if Venus does move around the sun and has no light of its own, we would expect that crescent which is near us to be very large, and the full disk which is far away from us to be very small, and the half disk here and here to be intermediate between the two. Now let's look at what Galileo actually saw. Here is a series of photographs made at the Lowell Observatory in New Mexico. They show us the appearance of Venus as seen through a telescope at constant magnification. Here is the disk, the position roughly resembling the last quarter, and here is the very thin crescent. Note that the relative sizes accord perfectly with the prediction we made a moment ago, when we assumed that the planet Venus moves around the sun, that it's like the Earth and like the moon, and not like the stars, that it has no light of its own, but shines only by reflection. Now, let's put all of these discoveries together, and let's make as our final assumption that what happens in one planet can be assumed to happen in most of the others. The system is one in which the Earth shines like the moon and presumably shines like the other planets. The moon is corrugated and rough and like the Earth, and so presumably are the other planets. Some of the planets like the Earth have moons. The planets shine by reflected light from the sun. They're Earths. They aren't stars at all. And so you can see that at once it wasn't philosophically absurd any longer to think of the Earth as a planet, or if you like, to think of the planets as being Earths rather than stars. And with the publication of that book of Galileo in 1610, the whole climate of opinion in regard to the discussion of the Copernican system was radically altered. The effect of the new instrument had been to take that statement, the Earth is another planet, which had been contrary to all sensory experience showing the planets to be stars rather than Earths, and to transform that statement into one which agreed with a new kind of experience. Since the telescope had shown that the planets are Earths, surely Mars, Jupiter, Saturn, Mercury, and Venus, being like the Earth, should behave like the Earth. And how reasonable now that all of them should move around the sun. The Copernican hypothesis, therefore, was no longer merely a mathematical device for computing. It was a reasonable description of the universe. And so we can understand why Galileo's message from the stars created such a sensation. All of the traditional ideas of the universe as a small, tiny place, the fixed, immovable center, had to be abandoned. And not only scientists, but philosophers and men of affairs and statesmen, poets and artists were shaken by the frightening ideas of the vastness of space and the new system of the world. The perplexity of those thinking men who now had to consider that the Earth was really a planet twirling around with no fixed location in space, an insignificant speck in the vast starry reaches of heaven, this feeling is perhaps best expressed for us by a contemporary poet. Here, John Donne. A new philosophy calls all in doubt. The element of fire is quite put out. The sun is lost and the earth, and no man's wit can well direct him where to look for it. 'Tis all in pieces, all coherence gone, all just supply, all relation.
This is